Hello, algebra students. Welcome to Chapter 7, Section 7. This will be the last section that we do for this chapter, and we need to look at some applications of exponents, and those are called basically growth and decay. I think one thing I want to get out right up front is that decay does not literally apply only to things that are decaying, like I don't know, materials. It basically means anything that declines or decreases. So we could use the word decay to talk about like money, like losing money over a period of time at an exponential rate. We might say that the money is decaying. So it's not just a physical, tangible decay. We need to think of it in terms of something decreasing, and that might help clarify some of the issues we run into a little bit later. But keeping that in mind, let's just jump right away, get moving through things. Here in front of you should be this note template. You can find it on my website, I hope, if it's posted correctly. Let's do some matching for a little bit of review here. You've got column A as a situation, and you've got column B that is an equation model of each of these situations. So let's just start with number one here. The first one, a person begins with $100 a day and earns $2 each day. Well, basically what's happening there is you're taking 2 times the number of days and you're adding that to $100. And that's the middle one right there. So that first one, number one, there matches to 100 plus 2 times x. Now think about these as we go through them, because as we move into exponents, it becomes a little new for us. Number two says a person begins with $2 and they earn $100 each day. So that's 100 times the number of days, which would be x plus 2. So that's the last one right here. And so obviously when we know the last one is going to be the first, but I'd like to talk through it and please listen carefully. If you begin with $100 a day, but then every day the money doubles, okay, that means you're getting 2 times whatever you have before. So that might be like you have $100, and then the first day you take that times 2. And then the second day you take that value times 2. And then the third day you take that value times 2. So that's day 1, day 2, day 3, and then you take that times 2. That would be the fourth day. So what you really have there is 100 times 2 to the power of however many days I've gone there, and that's why it's 2 to the x if x represents the number of days there. So x in all three of these represents the number of days, and those equations model that. Okay, with that said, all right, let's go down. What we're looking at here is one example that we'll look at is called compounding interest, and that's a growth. And we'll also look at some decaying things. And so we're going to jump into that. Compound interest is when you earn interest on both the principal and on the interest. Now, I'll tell you something. My personal story here. My dad was a banker, and he talked about money a lot. And compounding interest is a key thing that people who do well with their money understand the difference between what's called compound interest here and simple interest. All right, this compounding interest is the one that can really pay off for us and can turn our money into a lot more money faster than simple interest is. And it gets a bit more complicated, and we will see that. You'll see that if you take business classes down the road. But I'll talk about that a little bit because I think it's interesting to me. Principal, we need to know that the principal is an amount of money that you deposit in the bank. So that's actually number two. Number two says the amount of money deposited into an account is called principal, just like the principal of the school. It's actually spelled the same way. Principal, oops, and I can't spell it right. P-R-I-N-C-I, PAL, P-A-L. Number three here says the amount of money earned on the investment only. Okay, the investment only. Again, we're kind of getting into business class like things, but investment only earning is called simple interest. Okay, and that's better than nothing. All right, but what we would prefer to have is what we have in number 4 here, is where you earn interest on both principal and interest left in the account. That's called compounding interest. Now, what that means is if you have an investment over a long period of time, let's say year one, you earn interest on your investment and you keep the interest in there. On the second year, you would earn interest on both the money that you deposited plus the interest you made the previous year. Now, if that happens over and over for say 10, 20 years, you can end up making a whole lot of money on an investment if you allow time to be an asset for you. And that's what compounding interest is. And it's much better for your earnings over a long period of time than simple interest is. All right, so really the one word you are going to have to apply is you're going to have to know what principal means and interest and how these work together into an equation. We'll see in a few minutes. Let's move on down here to number 5. It says use the situation below. Identify the principal, the interest rate, the time in years, and the balance in the account. The balance in the account is how much money is in that account at this particular moment. All right, well, if Suzanne deposits $1,200 into a bank that pays 1.25 interest compounded annually, okay, that's good because it's compounding, it's not simple interest, at which point the account holds $1,276.90. Okay, right now we're just identifying the pieces of this, okay? So let's just fill in the blanks here. The principal, what's the principal in this situation? Which is the same as that has right there. In the situation, the principal is the initial deposit. So the initial deposit was $1,200. Okay, so that is called principal. You need to know that. The interest rate is 1.25%. Now, we will use that. If we use that in the math equation, we have to use that in decimal form, which is 0.0125. It's just changing a percentage into a decimal. The amount of time in years is 5, right? 5 years. There's 5 years here. And the balance at the end was $1,276.90. Okay, so what we're doing there is just identifying the different pieces there. So this is just an introduction. So don't worry don't worry right now about why this value is that and why this is that percentage rate. Right now, all I want you being able to make sure you can do is understand the words and what they mean here. Okay, let's skip over to page 2 here as this we get deep into exponential concepts here. First, we're going to talk about exponential growth. Okay, so exponential growth means that something is increasing. Now, this is really important here, and you're going to have to spend some time studying this. If we have this function, y is equal to a times b to the x. Now, before I go on, let me go back and show you remind you what we did on the very first slide, which was this equation right here. Or you kind of see that pattern, y is equal a times b to the x. That's on the front page of your notes. Okay, this is the same thing here on the second page of your notes. Y is equal to a times b to the x. Now, this is really important right here. A is greater than 0, okay, and b is greater than 1. That models exponential growth, all right, and that b, that base b, is called a growth factor. Growth factor. Okay, that means this value as time goes on is going to grow, and exponentially it grows quite quickly. That b is greater than 1. That's really important that you understand it's greater than 1. And if we were to graph it, it comes out looking like this. Now, we did this last week in class where we graphed some equations, and we noticed that the one that went like this, when we did, I think y equals 2 to the x, that b value was greater than 1. It was 2. It was y equals 2 to the x. 1 times 2 to the x created this graph. Okay, so this is so important that you understand the base, which is greater than 1, is the growth factor. Okay, so you need to know that that value b is called the growth factor. Okay, if we have a value where that is decay, okay, that means that it declines over time. It declines. All right, notice the difference here. A, this number right here, this a value, is greater than 0. But right here, 0 is less than b is less than 1. So in other words, b is between 0 and 1. When b is between 0 and 1, we have a decay factor. And what that means is that the value is decreasing, and we would have a graph that came out looking something like this over a period of time. And last week when we graphed it, we had an equation like this: y equals 0.5 to the x. That number was between 0 and 1, and that went like that. And you graphed it, if you did your work in class, you graphed it and it came out like this. Okay, I'm at 10 minutes and that went fast, but those vocabulary words are huge for us. I'll be right back and continuing from this point in our notes.